of field physics as it emerged. Maxwell's Treatise of Electricity and Magnetism, on electricity and magnetism. In fact, this is one of the last times that innovative science of this kind really got published as a book at all. And it's interesting that Maxwell himself speculated that old metaphor that nature might be a book, or such a thing as the book of nature, might be outdated, and that we had to think of nature now as a periodical, as a scientific journal, instead of as a book. So that world of the philosophical transactions is just becoming supreme with the emergence of the disciplines, as this is the last of the scientific books, if you like. The treatise is incredibly complicated. Almost nobody at the time could read it successfully, if you take successfully to mean how we would read it. And it was very difficult to produce, too. There's a very interesting history to how it was printed and how books like this were printed, because the techniques of representing mathematics on the page were very new to typographers. It accompanied Maxwell's appointment as the Cambridge University's first Professor of Experimental Physics ever, a post that came with the launching of another novelty, a place, the laboratory. Cambridge's was called the Cavendish, which is here. For what it's worth, this is now the Department of History and Philosophy of Science in Cambridge, so this is where I was educated. It was always rumoured that it was full of radioactivity because of its status as a physics lab in World War II, but nobody's ever proved that to be true, I think because they don't want to. So this is where this book came into being. And briefly, the key to the fame of this book in modern terms is that it describes an all-pervasive electromagnetic ether in terms of a field. And the dynamic properties of this field explain a vast range of electrical and magnetic phenomena. The field theory became, in the end, the foundation for all radio and light research. So all of our wireless communications go back to this book, in a certain sense. It itself, though, was designed to help students, especially very, very skillful students, address the return of physics to the exam structure in Cambridge. And it's written for that purpose and with that in mind. You can only really read it in conjunction with extensive skills and practices that involve doing complicated mathematical formulae with pencil and paper. That pencil and paper, the physical movements of the hand, actually, are a key part of understanding how this book came together. In particular, Cambridge's environment effectively created 3 books out of this one, depending on how it was read in 3 distinct kinds of places by 3 distinct kinds of audiences. Some of them, for example, one of the things that's interesting about this is that the different groups that read the book literally did not read parts of it. And some of the parts that particular groups did not read ended up being, for us, the most important part of them. That's true of the first regime, which is that of applied mathematics, taught by the superb private tutors who existed to take the very best of the students through the incredibly competitive Cambridge mathematics exam system. The most renowned of them was a man called Edward Ralph, at the centre of this picture, who did teach the treatise, but he taught it in terms of old Newtonian theory of action at a distance, where you have points of attraction and repulsion, where forces interact between those points. There's nothing here about fields at all. And it's pretty clear that he made no reference to fields or to the electromagnetic theory of light or anything that eventually became the reason for the existence of the book. The second culture is that of experimental physics, taught by Maxwell himself in the Cavendish lab, seen here in its interior, where the book was part of electrotechnology. It was the key to building better submarine cables, for example. This is the great age of telegraphy. It was the key to experimental physics, not mathematics particularly. What's interesting about this is that Maxwell, the author of this book, found that he was very unsuccessful in teaching students. The reason for that being that this kind of skill in experiment was not in the exam. So it fell under what a German colleague of mine calls the category of luxury knowledge. So his numbers of students declined, and by the time Maxwell died, in an untimely fashion, this culture was really on the wane. The third of the cultures was highly theoretical and had to do with the very highest quality mathematics students. And it was taught by college-centred tutors, in particular W.D. Niven, seen here, who taught at Trinity College, the richest and largest of the Cambridge colleges, Newton's Old College. And this was the only venue, actually, anywhere, where the treatise was consistently seen as a tract about fields, as about what we now take to be its essence. And in fact, Niven personally trained in these pencil and paper tests about fields. Every single person who in the next 2 generations was regarded as a Maxwellian, that is the founding generations of modern physical theory. Every single person came through the reading environment pioneered by Niven, with one exception, who was a famously eccentric electrotechnologist called Hemeroteca. If you ever come across him, he's a fantastic character, but he was the only one. In fact, after Maxwell died, Niven and his community of readers re-edited the treatise to make it into what it now is. In fact, what the treatise now is the combination of Maxwell's original work, which is actually different in significant respects, with all of the misreadings that were done by students, which had caused them to go back in a circulation process through Niven to Maxwell himself, and to rewrite the book, firstly under Maxwell's aegis and then under Niven's after Maxwell died. So what happened the treatise as we now have it is a product not only of Maxwell, even though it's under Maxwell's authorship, but a product of Maxwell plus the collective misreadings and failures to read of this elite student audience. So what was happening in these readings was not a transfer of physics knowledge at all, really, but a reconstrual in quite different circumstances, and one that fed back into the book itself, making the book what we now take it to be. And it's because of that we can now look at audiences like that and those of Routh and of Maxwell himself and say that they were, quote, misreading the book, unquote. We can only say that because the book that we now have is the product of their misreading. So what's elided in that kind of move of saying that these were misreadings is precisely the whole practice of reading and circulation that gave rise to the book as we now have it. So that process, the process of mediation that began with Champollion and his like in the courts, has now become a very highly specialised, exam-oriented enterprise dictated by people like Niven that feeds back into the structure of the science itself that we now have. So let me try and conclude by giving a sense of a preliminary kind of taxonomy chronology of the history of scientific reading based on these kinds of proto-epochs, if you like. What we see through examples like these is the power not just of reading in the abstract, nor of holistic notions of reading, like reading revolutions, nor necessarily of particular media technologies, but of particular conjunctions of practice, sociability, and genre that become institutionalized and develop a certain kind of lifetime to themselves. These conjunctions aren't reducible to the mere impact of anything like a technology, nor of a genre for that matter, say the internet or the scientific article. The causal nexus is always far more complex than that. And the history of scientific reading would have to be the history of these conjunctions. Their making, their nature, their change over time, and not least their consequences. And of course there are far more of them to deal with than is implied by a simple chronological typology like that's presented here, which traces the concept of reading as mediation. To take only the most obvious omission, for example, there's nothing here about popular reading, which is a key part of the story, not least because popular reading is never only popular. It always goes back and feeds back into expert cultures. So I've guessed here that we have successive, if you like, ideal types, which I've traced out 3 of, and the last of them might be, or at least the latest of them, might be the mechanization or automation of reading in today's data-driven science. To take that last line then, if you have a series of heroic reader figures, or author figures, associated with particular institutions, particular vehicles of reading, particular enterprises of reading, particular models of the civility of reading, what at least the boosters would say that we're heading into now is a radical break from that history, where instead of having human readers based on a kind of evolving historical set of norms, what we have are digital algorithmic readers, bots if you like, that precisely escape from the limits of the disciplinary histories that we've inherited. No one reader could ever have the properties of this kind of bot. The whole point of this, for its boosters, is that any human reading skill depends on the cultural formation of the human reader, which means they're constrained by discipline, by background, by education, by language, as in my case, by place, and so forth. In a world of, though, harmonized digital, not just individual databases, but multiple databases that can be cross-searched, there is the potential to create automated systems that would supervene once and for all those limits of humanity, those limits that historically constituted supervene history. This is what automated systems do. For example, thanks to the world of open access science publishing, it's now possible to do what's called literature mining, where you take the massive corpus of literature text, millions, tens of millions of scientific articles, you search for them for, say, a property of molecule A. In one subdiscipline, to which human readers will typically be restricted, molecule A will be known to affect molecule B. In a different subdiscipline, to which there will be a different community of human readers, molecule B will be known to affect molecule C. No human reader, so the theory goes, will ever make the connection that therefore molecule A has an impact on molecule C, because we're constricted by history to being subdisciplinary. We're the heirs of Niven's teaching cultures, of the Royal Society, and ultimately of Galileo's Vinci. Bots, though, are not constrained by that, according to this notion, and they can actually generate scientific hypotheses. We can automate not only the reading, but the creation of scientific hypotheses themselves by virtue of automating reading in this way. It's as though a Galileo could have cross-correlated between, say, Ulisse Aldrovand's natural history, Tycho Brahe's celestial history, and Joseph Scaliger's world history, and plucked from them hypotheses about providence. Well, actually, I think Galileo probably could have done that, but Galileo was unusual. Living in a disciplinary age, it's harder for us to do this. We live in the world after the 19th century formation of technical disciplines. And this is actually going on. This is not pie in the sky. The bioscientists are doing this right now. And with the emergence of Google Books, once all the legal problems are sorted out, and once things like OCRing has developed degrees of coverage and degrees of accuracy that could be worked with, which is not now, but will be in the future, we can see this happening, and we see the humanities and social sciences too developing in this kind of direction. The thing is, if this is new, or even if this isn't new, what should we be concerned about its emergence, as well as why should we be excited about it? I think its potential is clear. The concerns, though, might include things like it makes us dependent not just on the collections, on the databases, but on the algorithms of search and analysis that are used. And these algorithms are often proprietary, or at least confidential. Or they're so technical that they're hard to investigate. There are not so many independent algorithms that this can be assumed to be a non-issue safely, especially as the whole point is to look across disciplinary divides. So it's hard for human communities to have something like a check on the suggestions that the algorithms make. Perhaps we risk replacing one set of blinders, that is disciplinary ones from the 19th century, with another set of blinders, that is algorithmic ones from the early 21st century. And at least the disciplinary blinders are relatively easy to perceive and therefore counteract, because we understand something about their history. We're familiar with doing the history of disciplines. And these algorithms, moreover, insofar as we do know about them, often partly work by recursively incorporating the outcomes of existing readings. That is, they're like Google search techniques where they create kind of systems of preferences by looking at what people have searched for and what answers have appeared before. As a result of that, there's the possibility that we risk making our sciences, and latterly our humanities, dependent on mechanisms of reading that actually constrict the range of possibilities by prematurely zeroing in on relatively uncontroversial consensus viewpoints. The outliers, the uncontroversial, the genuinely new, may be missed precisely because of this kind of algorithmic structure. So we may be narrowing the sciences exactly as we think that we're massively increasing them. And there is even a certain amount of evidence for this. I have a colleague in Chicago, a sociologist, who's done searches through tens of millions of scientific articles and has come up with quantitative evidence that as the range of digital searches expands, so that the zeroing in on consensus outcomes happens faster, and there's a certain evidence that it's constricting the possible range of answers too. It at least turns out to be sure. It turns out to be very hard to be sure that this is not happening. So we're in a promising but perilous moment when the historian of reading, and in particular the historian of scientific reading, has a special role to play. These historians can help us, society at large, as well as the sciences in particular, take a constructively critical perspective on the constitution of knowledge out of the world of evidence that we are now moving into. We can develop a better, by which I mean more nuanced, conceptualization of what exactly it is that we're trying to automate here, and what exactly we may lose as well as gain when we do automate it. So I'll stop there.